Hey, in this video we will be taking our vector class, turning it into a template class, instructions for the compiler to create any number of very similar classes, but that store different types of information, different types of data. So I am in Visual Studio with my, my vector class. And I first want to add a couple of features here that would make it so I can actually print things out from it. Maybe like, let's get a size function that'll just return the size internal variable. And let's say the at function, where we'll specify an index, and it will return just the element at that index. Alright, so now we should be able to actually test our program here, our vector class. So let me add a new main source file here. Try that out. Alright, I'll include my vector.h header. Alright, so with those functions implemented, I should be able to test it out. Hopefully it works. Let's make a vector called v.pushback. So we want to add a value. Let's add a lot of values. I know that my default constructor is going to make space for 10 elements. So let me make sure that I add more than 10. Let's try 20. And then we can see that this is all working correctly. All right, just put that in there. And then we should be able to loop through all of these now using the size we get from the vector, and print out each of these elements. v.at. Let me make this print out nicely. There we go. Let's try it. Okay, so I get the values 0 through 19. That's 20 different values, and it looks like it worked. Once it got to 10, it needed to grow each time in order to store another one. Okay, so I would like to now change this so that it doesn't just store integers. My vector class is still just as inflexible as the string bag in that case, that it only works for integers. So what I'm going to do is change this so that I use the template keyword and specify a type name for our generic type. I'm going to call it capital T. So now everywhere that I use integer as the thing that I'm storing, I need to change it to a T. Alright, so I have to be careful here because there are other integers I'm using that should stay integers. Yeah, values, elements, those are more generic words. Capacity is still going to be an integer, size is still going to be an integer, but contents is going to store T's, whatever these objects are. Floats, strings, integers, whatever. Okay. Pushback is going to take a T value, whatever those are. Yep, that looks good. And when I make an array, it actually needs to be an array that points to values of type T. There. That all looks fine. Yep. And my at function is going to return a T. That's what's stored at this spot in this array. An array of T's. And I think that's good. So let's see. that's not too bad. Let's go back to our main function. So now it tells me that argument list for class template vector is missing. It doesn't know what kind of vector to make. Since vector can now store any data type, not just integers, it's underspecified. It doesn't know what to do here. So I need to say with angle brackets what type it's going to be instantiated for. So this is going to tell the compiler, make a version of that class from the template that works for integers. And I could do this for other things as well. Let me just make sure that this all works out fine. Yep, looks like it works the same. Now I could make a vector of, let's say, strings. Let me call this string vector. And then I can go and push back a string. That'll be stored in there. This says push back. Just push back take. Oh, I'm doing V. That's why. Using the wrong vector. String vector dot pushback. And then I could print out string vector dot at element 0. So that should be hello. Alright, great. 0 through 20, or through 19, and then hello. Two different containers, each a different type, technically, but they're both based on the same template vector. A template that can generate containers for any data type that can grow to hold as many elements as you need. Awesome. So the process for doing this is fairly straightforward. We go through, we add the template declaration, template type name T, and then go through and replace all of the places where we needed a generic type with that T placeholder. There are some kind of side effect things that we need to think about a little bit here. Depending on what T is, returning it this way could create a copy. So we'll need to talk further about what to do in that case, how to avoid those copies, and if you remember what we did about that before, then you're on track. See ya.